So good afternoon. Welcome to our last session on financial analytics. First of all, I'd like to take this opportunity to thank you so much for the term that is soon to pass. I really enjoyed the class with you. Thank you so much for your participation. You were one of the classes that were really cooperative and were really focusing on the lesson. So maraming salamat. Okay, so what we're going to discuss is briefly, we will not have the time to really go into the nitty-gritty details of this, but what's important is that for us to have an idea, what is random forest, what is support vector machine, and what is artificial neural network. There are other algorithms that are used for other purposes. But as far as classification and regression is concerned, these three are very powerful. Okay, so that's why in your case two, you're supposed to do a classification uh, model for a particular variable based on your data, and then you have the features or you have the independent variables there that you're going to use in order to predict your outcome. All right, first is random forest. What's random forest? We learned before the concept of a decision tree. A decision tree comes up with a model by nodes and branches in order to predict your. It can be also a categorical variable, or it can be regression. So decision trees can also be used for regression, where the variable of interest is a continuous variable and not a categorical variable. In the same manner, si random forest, it's just like a decision tree in steroids. So which means that decision trees can only create one tree. For random forest, you can create thousands of trees so that your output will be more robust compared to a decision tree. Okay, take note, the difference is that decision tree, you can only create one tree at a time. For random forest, you create actually thousands of trees. That's why it's called a forest. So it's a versatile and powerful supervised ML. You know what supervised means? It means that your features, your variables are defined. It's used for machine learning algorithms, used for both classification and regression. So how it is this done? You construct a multitude of decision trees. Okay, so that's like the decision tree which we did before. You imagine creating that decision tree, but thousands of decision trees. So that will make your output more reliable. Okay, so again, we split our data usually into two, into training and testing. All right. So how does random forest work? What's important here is the concept of bootstrapping. Ito yung importanteng concept sa random forest. Ano ba ibig sabihin ng bootstrapping? Bootstrapping means you generate several data, several samples from your data. Okay, so that's why you're able to create several trees, is because you have several sample trained data, for example. So RF builds on multiple decision trees by sampling in the training data. Okay, so what does that mean? So for example, you have 100 observations. You can create different thousands of sample data for the training data for your sample coming from your original data. And this is possible because of the process called bootstrapping. Okay, there's a particular package that's very powerful as far as bootstrapping is concerned. However, yung random forest na package can already on its own generate bootstraps. No? So it means that each tree in the forest is trained on a bootstrap subset of the original data set. So this is possible because you do sampling with replacement. Diba? When we say replacement, you get a sample and then you can put it back. Okay, so that na-maintain yung original size ng data natin. Kasi kung walang replacement 'yon, edi pakonti na lang pakonti yung matitirang di ba? You'll have less number of observations, therefore you cannot possibly create multiple multiple subsets. Okay, so I have here some explanation, but we will not really double into this. What's important is that you learn that there is a process called bootstrapping. Okay, so it's a technique used in statistics to estimate the sampling distribution of a statistic. So we repeatedly resample with replacement from the observed data set. Okay, it is particularly useful when the underlying distribution of the data is unknown. So kunyari, hindi natin alam kung yung underlying data natin is normally distributed or t-distributed siya. Okay, so importante yung bootstrapping kasi we are able to generate many samples from the data. So how is it performed? Yung bootstrapping, it's performed through sampling with replacement, which I mentioned a while ago. Okay, so it's able to create bootstrap samples. Each observation in the original data set has the same chance of being selected for a bootstrap sample at each iteration. Okay, so it means, for example, observation number 55, since you use it first, you got it for the first bootstrap, then you return it to the original sample. So observation number 55 will have again, may also be used again for the next for the next bootstrap. And there's a way to do this, no? Sorry. Excuse me, class, huh? So each observation has the same chance of being selected for a bootstrap sample at each iteration. All right, then after you have your bootstrap samples, after creating this, thousands or more, then the statistic of interest, either it's the mean, median, or the regression coefficient is computed for each bootstrap sample. So imagine that, plus creating several thousands of bootstrap samples and then creating from each of them your statistic of interest. It can be your regression coefficient, etc. Okay? All right. So these are the other features of your random forest. Random feature selection. At each node of the decision tree, instead of considering all the features for splitting, random forest only considers a random subset of the features. So this again is a very important feature of random forest. For example, you have 20 features, or which means you have 20 independent variables. What will be done is magsa-subset din siya. So it's not only the observations that it's subsetted, also the independent variables or the features that are subsetted. Okay? So for example, for one for one sampling distribution, you have these four features, you have these four independent variables. For another, it may be a different set of features or independent variables. So because of this, talagang nararandomize yung trees natin. And it helps prevent overfitting. Imagine you have thousands of sampling distributions, di ba? Okay? Tapos the features of decision trees is used until it reaches a stopping criterion. Okay? So these are the added features of random forest. We'll not go into the nitty-gritty details of that. There are certain advantages of random forest. Number one, robust siya to overfitting. Kasi nga, you have several sampling distributions. You have thousands of them containing samples of coming from different observations and also samples coming from different features. Okay, so it can handle large data sets very efficiently. And because of the implicit feature selection class, ito yung sinasabi natin kanina, that we allow, the random forest allows that you have subsetting also of your independent variables. Overall, random forest is a popular choice, okay, from any ML task because of its robustness, flexibility, and madali siyang gamitin. ease of use. Okay, next, SVM. Okay, ano importante sa SVM class? Sa SVM, ang importante yung tinatawag nating hyperplanes. Okay, so how does a hyperplane work? I'll just illustrate a two-dimensional plane. Suppose this is your data. Okay, so SVM class, what happens is that you create a plane that tries to separate your data. So for example, baka pwede ito yung plane natin. Plane. In this case, our plane is a line. So we separate the two. Kung two-dimensional lang naman yung inaan natin class, pwedeng line na ganyan. No? So how is this determined, itong plane na to? You try to get, you measure the distance between the points and the plane, or in this case, the line. Okay? So yung line na to, okay, if you sum up all these distances, summation of the distances, yung differences niya from the plane, it should be maximized. No? So mina-maximize natin yan. Okay? So it's easy to visualize this if it's only a two-dimensional, kung line lang yung 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 pinaka hyperplane natin. However, mahirap yung class kapag three-dimensional na or even multi-dimensional. Okay? So as I said a while ago, nagka-create ng plane yan, separating by hyperplane. The support vector machine aims to find the optimal hyperplane. Okay, that best separates, ito yung sinasabi natin, separates the data points into different classes. Pag dalawang dimension lang, line lang yon, yung hyperplane natin. Pag three-dimensional, it's a plane. So imagine yung class, XYZ axis, tapos on that plane class, three-dimensional, andun yung mga points natin. So how do you split the points? You use a plane. You can of course check the internet, no? Kung sige, magkuha tayo ng example dito. Okay, let's see. Hyperplane, para ma-visualize lang natin for SVM. Yan, klase na nyo. No? Yung sinasabi ko, ito. No? Maybe there are others. Ito line lang eh. Yan. Ito class ito. This is an example. So, di ba nagka-classify tayo, no? We're classifying. So, how does SVM do it? This is a three-dimensional plot. So, how do you separate? Ito yung mga similar, yung red at saka yung blue. How is this separated, class? You use a plane here. Yan. Pag three-dimensional. Eh kapag multi-dimensional na, ang hirap na i-visualize nun. No? Ito yung line lang, no? Ito. So madali lang to, no? Ito. So if it's just two-dimensional, so tingnan nyo yung support vector dito. It's either this, ito ba yun? Or ito ba yun? In this case, it will be the blue one. Kasi pag kinuha natin yung distances ng mga points dun sa line, okay, the summation of these distances is maximized. No? Yun ang objective natin. As compared to this one, kung red class, so although malalayo itong iba, no, pero yung iba ang lalapit naman. So in this case, basta ang concept ng class, ang concept ng SVM is to create this this plane, no? This plane. Okay, so this is our plane. This is the ito yung support vector natin, class. Okay, itong quote-unquote imaginary line. Okay? Yung edge ng isang group at saka edge ng isang group. Okay? All right. So, I hope that's clear, class, no? Yun lang kailangan natin. We will not go into the computation of this. We will just use R in order to generate the plane for us. Okay, so ito sinabi ko, class, maximizing the margin. The optimal hyperplane is the one that maximizes the margin, the difference between the actual points and whether it's a line or a plane, yung distance niya. Okay, so there are some other features here like yung kernel trick. Okay, so kaya niya ng non-linear, no? Between the features through a kernel trick. Okay, so this is quite difficult to visualize, but what's important is that kaya ng SVM na linear, kaya niyang polynomial, kaya niyang RBF, no? Yung radial. Okay, usually itong ang observation ko, yung radial ang nakakakuha ng magandang SVM. Okay? Okay, so once trained, the SVM constructs a decision function based on the support vectors and their associated weights. This decision function is used to classify new unseen data points into one of the predefined classes. All right, so may mga advantages din si support vector machine. So effective siya in high dimensional spaces. Kunyari maraming classifications, no? Maganda yung si SVM. Will perform well even in cases where the number of dimensions, okay, exceeds the number of samples. Kaya ano ibig sabihin nito? Yung dimensions natin class, ito yung let's say yung marami tayong features, marami tayong independent variables or marami din tayong yung classifications. Tapos konti lang yung samples natin. This SVM becomes very effective pag ganun. Random forest might not work in that case or might have not so good output pag marami yung let's say levels ng classification, tapos konti lang din yung yung atas marami yung independent variables or yung features, tapos konti lang yung size ng sample natin. Okay? So very versatile siya. Okay, and then what I mentioned a while ago, yung kernel trick, yung kaya niyang kahit na mga hindi linear. No? All right, so widely used in image classification, text classification, in finance, and also of course classification and so maraming gamit si SVM sa finance and even sa image, no? Sa image classification. All right, so that's how yung mga electric vehicles work. Electric car, for example, or yung driverless. Paano na malalaman na for example, may magko-cross na individual. Tapos kailangan niya mag-reduce ng speed. Diba? Image classification 'yon. So tao ba 'yan o pusa or is it a traffic light? So SVM can be used in that. And the third one class is ANN. Ito isa sa let's say medyo quote-unquote mysterious, no? Kasi ito class, minimimic niya yung human brain. It tries to imitate the human brain's biological neural network. So, ano yung ANNs class? Mga nodes siya. It consists of nodes, layers of nodes called artificial neurons or perceptrons, and it's organized in layers. These networks are used in solving machine learning tasks like classification, regression, pattern recognition, then etc. Okay. So, ang important point sa atin to understand is that yung ANN, it consists of the input layer. Ito yung gagamitin natin ng mga features in order to predict your output. So, meron tayong input layer, meron tayong output layer. Ito yung output na gusto natin. Okay, tapos merong hidden layers. Ito yung perceptrons na sinasabi natin. No? Ito class black box to. Kasi we don't actually know what's happening inside. Parang you put inside the model, the input, and the output, and then the algorithm will churn a weights for your nodes, no? For your hidden layers. Okay, which will show in a while. Okay, so yung experience ko dun sa kabilang section, natapos namin yung random forest, and then we jump to ANN. Tapos hindi namin nasimulan yung almost finish yung yung ANN. Pero yung support vector machine hindi namin nasimulan. So what I'm going to do later is that when I share now the code for random forest, after random forest, isi-share ko muna yung code for SVM para you have the copy already. And on your own, you can, if you want, you can try to decipher what's going on with the code. And then yung huli, we'll start first with A and N. All right. So, okay. I'll not discuss anymore how does A and N work. So, andyan yung forward and backward propagation. No? All right. So, ang advantage ng A and N class, nakakapag ano siya ng ano, kasi parang human brain siya. Yung neurons natin, it learns, no? It learns by experience, it learns by observation. So ito ganun din dito sa ano, sa A and N. Okay? So I'll leave you guys to look at the other notes here. How do you compare class yung kasi yun ang case nyo eh. Kailangan nyo ma-compare yung RF, yung SVM at saka yung ANN. Which is the better model based on your data? So first of course yung ano yung accuracy. Accuracy yung ilan yung tama niyang prediction, which you can of course generate from the confusion matrix, di ba? Na ano na natin yan. And there are other measures, F1 score, precision and recall, ROC curve, if it's yung receiver operating characteristic, if it's applicable, no? Then of course, may mga models kasi na katulad ng ano ng ANN. Medyo sometimes it can take long, especially if your hidden layer is quite complex, no? So medyo matagal yung ano, yung complex yung pag-compute niya at saka yung time. Okay? And then also robustness and generalization. Okay. So I wasn't really able to go through the comparison, pero isasama ko na lang siya sa added na summary video. All right? So these are the packages that we're going to use. So I'll see. I-chat ko na lang to. Okay, kindly just copy it. So random forest, of course, ito yung gagamitin natin for random forest. Neural net for the A and N. Also NNet, pero mas gusto ko yung neural net kasi mas powerful to. Si Carrot class, more on sa bootstrapping, napaka-powerful niya. All right. ESA 1071 is also used for ML. All right. So we're going to make use of the very popular na ano na iris dataset that comes prepackaged with R. Let's run this. Chat. I'm going to share this with you. Okay, in the interest of time. So our data is the iris dataset. Let's view this and get the structure and get the distribution of the species. So data ko muna to. Okay, so I have now the iris dataset here. Okay, so it's data, it's a data frame. And i-view natin. So what's inside this one? So it's a simple data set class 100. I just use a simple data set kasi again, yung time natin, time constraint, no? 150 observations and 5 columns. So ano to, no? This is a sample of 3 different types of flowers: setosa, versicolor, and virginica. Yung tatlong colors. And then mineasured flowers, I mean. Yung petals sila. Mineasure nila yung sepal length, width ng sepal, at saka yung length ng petal at saka width ng petal. Okay? And then, alam nila kung anong flower yon, di ba? So, this is a classification problem. We're going to use these features, itong apat na to, sepal length, sepal width, petal width, in order to predict if the flower is a setosa or virginica or versicolor. Yun ang objective natin dito sa classification problem na to. Okay, so let's first take a look at the distribution. So medyo balance yung data natin, ano? Because there are 50 setosa, 50 versicolor, and 50 virginica. Okay, so we got this from the table ng data set natin na iris, and then the variable is species. Okay, let me pause for a while and ask you if you're able to follow. Kindly chat, please, class. Am I going too fast or are you able to follow? I'll appreciate your feedback. Okay, good. Thank you. Thank you. Now let's also check the summary, the structure of iris. Structure niya, and we see that it's a data frame, no? Consisting of 150 observations of 5 variables. Si sepal length, sepal width, petal length, petal width, they're all numerical. And then species is a factor. And you know what a factor is. A factor is a character variable that can be used for classification. Okay, good. All right. Uh, so because species data variable is already factor, we don't need this anymore. In case in your data, which is highly unlikely kasi pare-pareho tayong pinanggalingan ng data, but just in case na in your paper, for example, kung yung variable of interest nyo is not a factor, you should convert it to a factor. So you know that this is how you convert a variable who may be just a character into a factor. All right. So we learned about this when we did the decision tree, no? We said that kailangan split natin yung data natin. For machine learning, we don't use all the data. Otherwise, it will render some overfitting on our part. Okay, so once again, i-share ko na lang to in the interest of time again. Kasi medyo kapos tayo sa oras, no? All right, so let's take a look at what we're doing here. Okay, importante siyempre yung set.seed kasi gagamitin natin itong mag-generate tayo ng random sample di ba? Ng mga numbers. So we have to use the sample. Okay, so we have to use set.seed so that pareho tayo ng mag-generate na na randomized numbers. All right, I'm creating this object called indices, and the function is sample 1 up to the number of n row ng iris. We know that the n row of iris is 150. Okay? So, sa indices na to class, ilan numbers ang i-generate? So here I'm using 0.7 times n row. Okay, so n row of iris is, so let's mga dito, n row of iris, we know that this is 150. Pag i-multiply ko siya ng 0.7, so 150 times 70%, that gives us 105. Okay. So medyo iba to class nun sa ginawa natin dati na nag-sample din tayo pero probability yung ginawa natin. No? Probability is equal to C and then 0.7 comma 30. Yun yung probability class, it will not generate exactly 70%, 30%. We saw that last time, di ba? Ito naman class, specific, 70% ng n row. So this is not probabilities, but this is really specific na 70% times n row. All right, so if I run this, let me run the first two, set.seed. All right, then let me check my indices here. Nag-generate tayo ng indices. If you run yung set.seed at saka indices together with me, then dapat pareho lang tayo class. No? Let me print indices. All right, so tingnan nyo to class, no? Number 99, 100, 101, 102, 103, 104, 105. So these are 105 numbers. Ano yung mga numbers yan? 14, 50, 118, 43. So this generated random numbers, no? From 1 up to 150, kumuha lang siya ng 70% no, ng 105. So these are the 105 numbers coming from the set of 1 up to 150. All right? Did you get it, class? Meron tayong 105 na numbers dito. Now, these numbers came from 1 up to 150, yung n row ni Iris. Okay, so isa-isa, no? Isa-isa. Okay, you got this, class? Paki-chat nga please if you understood that function. And if you were able to generate the same output as mine. Dapat pareho lang tayo, class, kasi nag-set.seed tayo. No? Okay? Dapat 14, 50, 118, etc. Okay. Now, one thing good about this is that if you take a look at our data iris, yung arrangement niya, tinan nyo. First 50 is setosa. Second 50 is versicolor. Third 50 is virginica. Di ba 150 yan? Ngayon, kung hindi natin ira-randomize yan, kunyari, sabihin natin, sige, 70, that's 105, no? 70%, that's 105. So the first 105 numbers, 105, no? First 105 will be for our index, no? 105, ito. Okay? So anong pangit dyan? Ang pangit dyan, class, dun sa index na yon, kasama lahat si setosa, kasama lahat si virginica, versicolor, tapos may konting kasama kay virginica. Ayan. Yung 5 kay virginica. Okay, so that will really skew your data kasi yung data mo na we're going to develop our training data set. Ang laman niya, kung kompleto na 50 na setosa, 50 na versicolor. So that will really skew your data class and you will not be able to come up with a good model. So very important yung how we churn out the this distribution. No? So from here, mag-create na tayo ng trained data natin class and it's coming from iris. So kukunin natin si iris dataset tapos yung rows natin will be coming from the indices. Okay, so ang row natin ito, yung row 14, 50, etc. Right? So yun, no? Okay, so i-run ko tong dalawang to. So we now have yung test dataset natin class is also from iris, kaso negative indices. Ibig sabihin, huwag mo isasama yung mga number ng indices. Do not include the indices. Okay? So all those numbers, the 45 numbers, kasi 105 to, no? So ang remaining 45. All those 45 numbers should be part of your test dataset. Okay? So let me check the trained dataset here. And if you take a look at the trained dataset, take a look at its composition, 14, 50, 118, 43. That's the indices class. Okay? So maganda kasi renumble na talaga. It's randomly generated, okay, which will make our machine learning algorithm more reliable. Okay, of course, yung test dataset, let me just print that also, are those numbers that are not included. Ayan, 1, 2, 3, 5, 11, 18, 19. These are the numbers that were not part of the indices. And they are 45 of them. Okay? 45 of them siya. Alright, tingnan natin class yung distribution ng ano. Okay, so ito, we checked a while ago. Ito. Kung paano na yung distribution ng ano natin, trained dataset natin. Okay, so it's 36, 32, 37. Not bad, no? Yung original natin na 50, 50, 50. So kung perfect yung talaga na pag-distribute, sana 35, 35, 35. But it's okay kasi ano to randomly generated din. So hindi naman sila nagkakalayo. Ang medyo bumaba lang ng konti si versicolor. Okay? So for our trained data set, 36 setosa, 32 versicolor, and 37 virginica. All right. Then, so magsimula na tayo class sa ano natin, sa random forest. Binigay ko na ba sa inyo to, class? Have I shared this with you? Itong random forest na to?
No,
Not yet.
sir.
Okay, sige. So, let me just also include this para yung notes kanina. Sige, ibigay ko na nga rin to. Okay. Tingnan ko kung kakayanin na. Minsan kasi kuripot to si ano eh. Yan, good. Sige, hanggang dito umabot sa ano, sa 185, no? Okay, so let me go up here. Okay, so how do we create our model class? So we're creating this object called random forest model, RF model. Now the function is random forest. Okay, for those of you who were my students in FinArts, parang LM lang yan, no? Linear model. Ito ang ginagamit natin, random forest. And then we are modeling species, diba? This is our variable of interest. This is our dependent variable. And we are associating it with that. Who among you know what this dot means? Anybody who was my student? You weren't able to send it? Ah, sorry. O nga, no? Wait, ha? Sorry. Ito na muna. Kasi naglolo ko minsan pag mahaba. Yan. Okay. Copy that, please. Okay. As I was saying, class, let's first create a model using the trained data set. Remember yung trained data set natin, ito yung 105 observations. Okay? For our testing data set, we're using the 45. So that's the concept, class, of avoidance of overfitting. Hindi natin ginagamit lahat ng data natin, observations natin. Split natin yung data. As to the question of ilang percent yung training, it depends. No? Pag medyo malaki yung data, okay lang naman na 80-20. It really depends. Wala namang standard na ano na rule. Okay. So 105 observations, 45 observations for the test, okay naman yun. All right. So ito, class, yung code natin. We're using the random forest function. Species regressed on that here means all. Okay, kaya class, those of you who were my students in FinArts, alam nyo yan, na dependent variable associated with all the predictors. Okay, and then our data is equal to trained data. Now, another way to write this is this one. Species, ito for this one. Species regressed on, you identify all the predictors, all the features, sepal dot length plus sepal dot width, petal dot length, petal dot width. Okay? So, shortcut na lang tong dot dito. So, pag yung data nyo, class, may mga ibang information na hindi nyo nang gagamitin sa pag-generate ng random forest, then you have to specify kung ano yung variable, yung mga features na gagamitin nyo. Okay? All right. So, we now have this RF model. Run natin to, Control Enter. Then I was able to generate now this data RF model. Ito siya, class. And it's a list of 19. 19 yung laman nito, no? Iba-iba. So many things inside this one RF model. If you take a look at that one, ito yung formula, no? Type, predicted. So may prediction na siya, no? Sinasabi niya kung ang prediction niya kung setosa yon, versicolor, or virginica. Error rate, yung confusion matrix, tapos other attributes. We're not necessarily going to use everything here, but let's just take a look at. Okay, since my model na tayo, class, may model na tayo. So what we're going to do now is let's create an object that predicts our trained data. Kasi di ba we generated a model, tapos tingnan natin, class, kung ano ba, kung okay ba yung pag-model natin. So here I'm creating this object rf underscore train underscore predict, and then I'm using this predict function. Okay, ano pinapredict natin? Using the RF model, i-predict niya yung trained data. Yan. Okay? So alam ni R, kasi RF model, ang pinipredict niya yung species. So alam niya na inside trained data is andito si species. No? Ito si trained data. Ayan si species. Okay? So gagamitin niya to. It's going to use this trained data in order to predict yung species. All right, so let's run this both. Okay, and you can see that medyo malaki yung result, no? Okay, so ito yung prediction niya. Sabi niya, si Setosa, si 14, Setosa. Si 50, Setosa. Si 118, ang prediction niya, si Virginica. So ito yung mga predictions niya, class. Okay, so lahat yan, 105 all in all. Ang mga levels, Setosa, Versicolor, Virginica. So based on the model, ito yung prediction niya. Tingnan nga natin, class, yung una. Setosa is number 14. Yan, is Setosa. So tama, no? Tama yung prediction niya dito. Prediction niya Setosa, 14 is actually Setosa. Okay? Tapos ganoon din, si number 50, 50 is also Setosa. 50, Setosa. Ang prediction niya, Setosa din. 118 is 118 is Virginica. Predict niya as Virginica. All right? So we can see here the predictions. Dito, no? Now let's generate, if you recall, class, yung confusion matrix natin, no? Okay, let's create this object, RF, random forest, confusion matrix. So I'm using the table function. And then sa y-axis natin, yung mga predicted values natin, predicted is equal to yung galing dito, no? RF train pred, coming from here. And then yung actual natin is coming from your train data. Okay, yung actual data which can be found in species. So let's run this. And you can see that yung confusion matrix natin, ano? Okay, i-print natin siya, class, no? Ito. Print, kasama yung title, confusion matrix for random forest on training data. There. So there you go. Oh, wow. Kamusta, class? Kamusta ang prediction using random forest? Class? Any comment, please? Very accurate, as in perfect, no? Kasi yung observation na to, class, 36 observations that were predicted as Setosa, lahat ng yon tama, Setosa. So, ganun din kay Versicolor at saka Virginica. Diba, class, if you recall, yung diagonals dito, ito yung correct observations. Yung mga off diagonals, they are the mispredicted. So, mali yung prediction. Pero dito sa random forest natin, dun sa training data set natin, na-predict na lahat, no? Okay? So, most probably because maliit lang naman yung data set, no? 105. So, medyo kinaya talaga ni ano. All right. Now, that's not the test actually, no? Ang pinaka-ano dito, class, tingnan natin kung how the model will work, how the model will fare if it's using a data that has not yet been tested, not yet been seen. Okay? So ito naman, punta tayo sa predict ng test data. So dito, I'm creating this object. Have I shared this, class? Hindi pa, no? Ano, na-share ko na rin ba to? Na-share ko na hanggang dito, right? Sa confusion matrix. This one, I already shared, diba? Now for this one, okay, so kay test data set, punta tayo. Pareho lang naman to, class. Magbabago lang naman yung ano nito. Magbabago lang yung data natin. Alright, sige, copy nyo na. Okay. So here, class, I'm creating this object RF test predicted. So this is for the testing data. Ganun din, class, predict natin using the same model, RF model, but the data that we'll be using is test data. So that's the difference. Kanina trained data, no? In order to generate the model. Ngayon naman, i-predict natin, gamitin natin si RF model, yung na-generate natin kanina using the training data set. But this time, we're going to use the test data set. So there. Okay, so we can print this also, RF test predict. Pwede din natin ma-print yan. Okay, and then it will tell us ito yung mga ano niya, no? Ito yung mga prediction niya. Okay? And then let's just generate the confusion matrix. So RF test confusion matrix, you can name it any way you want. Para lang ako hindi malito dito. Again, table. Ang predicted natin will be this one na. No? RF test predicted, and then actual natin yung test data na species. Okay? Don't make the mistake here na train data set. Mag-error yan. Okay? Kasi dapat i-compare natin yung na-predict using RF model for the testing data. No? Kaya test data dapat to. All right, so if I run this and if I print it, i-print ko siya to. All right, then we have this one. May isang error, no? May isang error siya. So one observation was supposed to be versicolor, no? Pero na-predict siya as virginica. But that's not bad, no? Isa lang. 1 out of 45 lang yung mali. So let's compute class for the, we did this before. Yung correct na prediction, which is just the sum of the diagonals, diba? Sum of the diagonals divided by the sum of all the elements in that object. Yung object natin yung RF test confusion matrix. There. Let me run this. So that's around 90+%. Yeah, 98% class. Yung accuracy. Okay? Ang accuracy ng model natin in using it for the test data set is 98%. All right? So this is also same din to, no? Same din to. Okay, if I run this, okay, text lang siya, no? Random forest accuracy is yung RF accuracy, which is this one. So ito class, kinuha lang natin yung mean ng RF test is equal to predicted, which is equal to test data ng species. RF test predicted dito. Ilan yung equal? Ilan yung equal dun sa test data? Okay? So in other words, class, ilan yung tama? All right, and then 97%. Okay, now root mean square error class. So kailangan yan for pag quantitative na class yung pag quantitative yung variable natin, pag continuous variable, yung Ramsey. Kailangan natin yan to compare the different methods. Now, pwede ba yan for categorical method? So ano ba yung nito? Tingnan niyo yung code dito, class. Nabigay ko na ba to? Nabigay ko na, no? Hindi pa. Have I, class? Not yet. Sige, ito. Alright, so this will just compute for the root mean square error, Ramsey. No? Okay, as we met this already before. It just gets of course, yung error, no? Square ng error. Ini-square siya, tapos kinukuha yung average niya, tapos kinukuha yung square root. So it starts with, take a look at this function. Kinukuha yung difference ng predicted at saka ng actual value. Get the difference and then square it. Yun ang squared natin. And then get the average. Yan. Yun ang squared error. No? The difference, which is your error, squared natin, and then you get the average mean, kaya MSE, and then you get the square root, no? Okay, if you run this class, what does it tell you? Kindly please feedback. What happens if you run this? Feedback, please, class. Okay, NA class, no? NA. So if I run this, it tells us that hindi pa pwede, no? Kapag categorical yung variables natin, meaningless yung Ramsey. Okay? So, we will have to use other metrics in order to compare yung yung sa case nyo, decision tree versus random forest versus SVM or ANN, which I said, kung gawin nyo pareho, may bonus, no? Alright, so unang-una, accuracy, pwede. So yung accuracy natin dito, 97.777 or 97.8%. Okay? Alright, may iba pang metrics which I'm going to discuss in the additional video. Alright, for this one, class, so okay na tayo with, with random forest. We were able to generate a model using the training data set, and then use the model in order to check, to run it for the testing data set and determine kung ano yung error ng testing data set natin. Okay, so that's the acid test, no? Hindi yung training, but the testing. Okay, for this one, SVM class, yung support vector machine, I'll just share with you first the code. Okay, i-copy nyo muna yung code class ng SVM. Tapos doon ko na i-discuss yan sa video. Alright? So, support vector machine. Okay, halos pareho lang naman siya, no? So, meron din tayong confusion matrix dito. Tapos, ko-compute din natin yung yung accuracy. And then, compare natin dun sa, compare natin kung sino mas maganda, yung random forest, or etc. So, let's go here, class, to ANN. Okay. In the interest of time, okay. Ito, class, nasa notes yun na to, no? This is in your notes. I will not share that anymore. Control C. Okay. If you want, you can, nasa bottom portion yan ng notes nyo. You can nasa taas siguro, no? You can copy it to this place. No? Okay. Dito medyo hindi kami umabot eh. Okay. Hindi ko masya. So, litan ko muna. Kunti lang naman yun. Dito muna sa 316. Okay, 316. Then, ito naman. Ito na lang natira. Kunti lang naman yun eh. Hindi pa inalaw. Okay. And then, i-ano ko na lang to class kung natitira, no? Using ko muna yan. All right, let's go to artificial neural network class. So remember class, ang artificial neural network, you have to define your input, and then your output, and then your layer. Okay? Your hidden layers and nodes. Okay, so we're going to use create ulit tayo ng ANN model class. Okay, let's not use that. Hindi kasi maganda class yung no? Hindi maganda yung... Sige, pag rinan nyo to class, tingnan nyo ha. Let's run this. Okay. Size 10. So nag-iterate siya. Nag-converge naman yung solution. Okay, so medyo hindi clear yung no? A 4, 10, 3 network with 83 weights ang lumabas. So soft max modeling siya. So I don't like the way it's presented. Okay. Kasi ito, sinasabi lang dito, from the base natin to hidden one. Okay? I don't like the presentation of this. So, ang gagamitin natin class, not NNNet, NNet, but ito, si neural net class. Okay, so this is coming from, you can see the difference in the function. Ito NNet, ito neural net. So I find this to be much a lot better. Ilagay ko nga ito dito. Oops, sorry. Mali. Okay, para mas kita natin. Alright, so I created this ANN. Overwrite ko na lang yung kanina, yung ANN model. And then I'm using neural net here. Same thing, no? We're associating yung species natin, okay, with all our features, sepal length, sepal width, petal length, petal width. Data this time, data is still trained data. So pareha pa rin, no? Kasi we're generating a model using the trained data. And then ito yung iba, no? Hidden. Ano ibig sabihin ng hidden na to, class? Now, pag dalawa to, ibig sabihin ng class, meron tayong 2 layers, okay? The first layer consists of 5 nodes, okay? This means 2 layers, 5 nodes, and 3, 5 and 3 nodes, respectively. Which means that for the first layer, 5 nodes tayo. For the second layer, 3 nodes tayo. So I'll show what this means. So i-run muna natin to. Make sure you have, although rin na natin yung kanina, neural net, no? Okay. So run natin to. And then makakakita tayo dito ng ANN model. Asan na si ANN model? Here, ANN model. It's a list also. It's a list of 14. So, i-run nga natin to. Anong laman ito? Okay, first, okay, first it gives us the data. Ito yung data natin. Tapos sa ilalim, ito yung net.result. Okay, so this is very important for us, class. Net.result. Ano to? So this is observation number 1, di ba? 14, 50, 118. And these outputs here are probabilities. Okay? These are probabilities. So, itong 14 na to, class, ang probability na 1 siya, which is setosa, versicolor, virginica. Okay? Ang probability na setosa siya is, compared to the others, class, this is 0.000753. This is 0.000049. So, maliliit yung probabilities itong 2 and 3. See, almost 1, no? Okay? 1. So, ibig sabihin nito, ang prediction niya, based on our artificial neural network is, yung setosa siya. Kasi ito yung pinakamalaking probability. Ganon din, class, kay 50, observation 50. This is the prediction, setosa din. Kay 118, ito yung pinakamalaki, no? Ito yung 1 na to. So, it's virginica. So, dun sa object na ANN model, under it is another object called net.result. Ito yun. So, pinapakita sa atin dito lahat ng predictions, no? Okay? Lahat siya. Alright, so let's tanggalin ko muna to. Hirap pa naman tanggalin to. There. Okay? Let's see what happens if we plot this class. Plot. Okay, and here. That's why it's better to use neural net. Kasi si NNet, walang, hindi nagwo-work yung yung plotting. Ito, mas maganda kasi nagwo-work. We can see here now the neural network natin. Yung model natin. Okay? Ito yung inputs natin, class. So these are our inputs. 4 siya. Ano to? Sepal length, sepal width, petal length, petal width. These are our inputs, and these are our outputs. Ito yung mga pinipredict natin, di ba? Setosa, virginica, versicolor. And inside, this is our hidden layer. Ito yung tinatawag natin na generate using a black box. Okay? So ito sinabi na ang error ng model natin is very small, 0.004984, and it took 7,835 steps in order to generate this. So milliseconds lang yan, bawat step, ano? Ang bilis. Tapos you have here numbers. Okay, we will not discuss the meaning of this kasi these are just weights, no? And nagbaback propagate siya, nababago-bago tong weights na to. And these weights are used in order to determine, okay, yung value nito. Okay, kasi ito may value, ano? And how did we get this? This was obtained by just multiplying, summing up all of this. Tingnan nyo class na ito, lahat ng features dito may contribution dito sa hidden node na to. So this is our hidden node number 1. All right? Okay, so this is the first layer. This is the second layer. Okay? Ilang layers ni ilang nodes ni first layer? 5. 1, 2, 3, 4, 5. Kasi di ba ang code natin hidden is equal to C, 5 and 3. 5, 2 layers yon kasi 5 and 3. Yung first layer will have 5 nodes. The second layer will have 3 nodes. Okay? And then from the second layer, okay, with 3 nodes, pupunta na siya dito sa sa output natin. And then each of the output receives contribution for each of the nodes, no? Second layer nodes. Okay? All right. So ito class yung neural natin, neural net. Which unfortunately is hindi nag-error ako dun sa sa nnet kanina, kaya I decided to change it into neural net. Of course, class, if we change this, okay, kunyari, gawin natin 2, tapos 2, tapos 3, kunyari. So, 3 layers na to, no? 3 layers of 2, 3, 2 each. So, if I run this, okay, so meron na, and then i-plot ko na lang, plot. So, you notice now that there are now 3 layers. Okay, 2, 3, 2. 2, 3, 2. It took 3347 steps, and yung error niya, 0.0024. Maliit din, no? Okay, so ang tanong, class, paano i-determine to? And you have here some guidelines, no? So, medyo basahin nyo ito ng konti, class. Determining the number of hidden layers. This one. Wala namang fixed rule, class, for determining the number of hidden layers. Okay? Often it depends on the complexity of the problem and the characteristics of the data set. In practice, pwede ka mag-start with a single hidden layer. Ang mangyayari naman dyan, class, the more simple the hidden layer, of course, i-compare mo with the other hidden layer, with other hidden layers, no? Based on the prediction. The less complex, the better. Okay? Parsimonious. Kung kaya mong ma-predict just using one hidden layer, mas maganda, di ba? Of course, you have to validate that kasi i-compare mo, for example, class. Let me just go here. Rule of thumb. Sabi dito, as a rule of thumb, you can start with the number of neurons between the number of input and the number of output. So, kunyari, 5 yung input mo, tapos 4 yung output. So, pwede sigurong, between, pwedeng 4 or 5, or pwedeng 3. So, that's a rule of thumb. So, kunyari ito, 4 inputs sa atin, 3 outputs yung sa atin, di ba? Pwede mong gawing 4. Kasi yun yung sa sa input O pwede mong gawing 3. O pwede mong gawing a bit more, pwedeng 5. One layer na muna. So in our case, kanina natin, if we do that, balikan natin yung ano natin, yung model natin. If I put here yeah, I need to say that. Okay, so let me run this. Gawin ko lang ano, kung isa lang layer class, hindi natin kailangan mag-concatenate. No? So ano lang to, 5 lang. 5. Open, close, okay. So here, sabi ko ang hidden natin 5 lang. Ibig sabihin, isang layer lang yan. Tapos with 5 nodes. If I run this, okay, so the more complex the model is, the hidden layers are, syempre, the longer the the longer will be the process. Kung ilang steps. Nag-aano pa siya. Nagko-compute pa. There, plot natin class. Okay, ito yung plot natin. Only one hidden layer, ito lang. And then 5. 5. Okay, so dito class, ang error natin 0.12. So mas malaki ko kaysa dun sa kaninang 5.3, no? And it took 53,511 steps. So mas matagal yung pag-process nito. Surprisingly class, kahit na yung isa 5.3, di ba? Right? Kasi yung 5.3 kanina, I recall 7,000 steps lang yun. Okay, so dalawang layers yun. Ito, isa lang, 5. Okay, anyway, so hindi natin alam kung ano nangyayari dun sa loob. So this is what we call black box siya. Box, no? Black box. Parang mystery siya sa loob ng ano ng neural network na to. Okay. All right. So let's go back here. Ibalik ko lang yung C at saka 5 and 3. Ito na muna gamitin natin, plus. Then let's go back. And then if I run this, so, ano to eh, yung tatlong layers. Okay, baka may question. Colin, can you share your question? And I'll ask the class what they think about this. Okay, class, what's the answer to this question? Do you mean, Colin, the steps here? Are you referring to this one or the number of layers?
The steps po there, sir.
The steps. Okay. Wait. Sandali, class, ha? Did you generate the 232 class? Yung hidden is equal to C, then 232. If you generated it, class, 232, okay, did you get the same error, 0.0024 and steps 3347? Feedback, please, class. Error is 0.0024 and steps is 3347. Did you? Okay, magkakaiba, no? So that means, class, nag-randomize siya, no? Okay. Colin, thank you for asking that kasi hindi ko siya hindi ko siya inisip kung mag-iiba yung yung result no ng pag-generate dun sa black box. So it all the more really ascertains na talagang black box yung nasa loob ng ANN na to. Okay? So saan na ako? So, Even class, paki-check nga ito, yung 5-3. So let's redo this. 5-3, tapos i-plot ulit natin. And let me have a quick survey class kung if you got the same steps and error as mine. I'm having 9289 steps and 0.0033. Okay. Looks like different class kasi kanina, if I recall, parang 7,000 yung different. Okay, so thank you, Colin, for that, no? So we will not get the same steps, no? And the same errors. Okay? So let's go now to the prediction. Okay, ito. Kakasya ba to? Ay, hindi. Right, ito. Siya na. Ito muna. Gandito yan. Okay. All right, let's take a look at the our prediction. Okay, there are several ways to predict this. Gagamit lang tayo we're going to use the compute function. Okay, so we're creating this object predict ANN train. And we're using the neural net again, and pwede natin gamitin yung compute function niya. Okay, so in order to have this prediction, ang gagamitin natin yung model natin, okay? And then yung data natin, yung train data natin class, using first, second, third, fourth. Ito yung mga inputs natin. So, yan ang syntax nitong compute function. Ito yung mga. Okay, so compute, anong model? Tapos, data, ano yung mga inputs natin? 1, 2, 3, 4. Diba? Ito class yung train data natin. Train, ito, 1, 2, 3, 4. Ito yung mga inputs natin. Okay? So using these inputs, okay, from the train data set, i-predict niya class, no? I-predict niya using the model that we generated. So if I run this, okay, so ano nang nangyari class? Si Fred, ito, no? It's a list of 2. I-print nga natin class. Fred and train. Okay, ito yung prediction niya. Parang kanina class, dun sa net result. This one. Okay? Neurons to, no? Yung nasa figure kanina, plus, ito yon yung mga numbers na to. Yung neurons. So, we will not discuss that kasi actually hindi naman natin alam kung paano generate yan, ano? Tapos ito class. No? Ito yung prediction niya. So, si 14, practically 1, no? 0.99999. The others are practically 0 hindi, sorry. This is 0.6. Sorry, neurons pa rin pala to. Sorry. Asan yung net result? My bad. They are still the numbers, no? Kaya pala sabi ko, bakit, asan na yung net result? Ito class, yung net result. Okay, same thing that I discussed a while ago. Si observation 14, ang probability niya na na setosa na 1 is practically 1. This is 0.0002. This is 0.00006 negative. So ito, setosa si 14. Okay? So prediction siya. Now, close ko to. All right. Saan ako? Okay, we viewed it, class. Viewed it. And then ito, sinabset lang natin, class, yung net result. Ito yung kanina. Okay. If you run this, class, have I shared this? Na-shared ko na, no? Sinasubset lang niya yung, dun sa object na predicted A and N train, yung probabilities yan. Okay. Para hindi na ma-print yung mga neurons. So yung mga probabilities. Okay, so what we're going to do here, class, is I'm just going to generate this, no, a data frame. So I'm creating this object, pred.2, okay, data frame, and then this is the function for each value in 1 up to 100. So this is the prediction for yung training data natin. Pred.2 is rbind, okay, row bind. Pagsama-sama natin sa row, yung pred.2, ito. Then which.max, pred untrain, and then net result ng I. So this just tells us, class, na tingnan niya, class, yung pred.untrain, yung net result niyan, hanapin niya yung maximum, no? Diba? Diba kanina yun ang pinakita ko sa inyo, yung pinaka-maximum, yun ang prediction sa kanya. Okay? And then ipagsama-sama natin sa yung mga rows na yan. Okay, if you run this, class, data frame siya, pred.2, i-print natin si pred.2. Pred.2 here, class. Ayan, yan. Yung mga numbers, class, ito na yung kung pinakamataas yung number 1, ilagay niya number 1. 113, it means this is the prediction for setosa, virginica, versicolor, etc. Kinonvert lang natin yung mga probabilities kanina into numbers, no? Kung sino yung pinaka-maximum doon. Okay? It's almost time, class, pero may I have this, tapusin ko lang tong konti na lang to, no? Naintindihan niyo to, class, yung ginawa dito sa pred.2? Paki-feedback naman, please. With simple coding, class, ang ginawa, ginamit lang natin yung net result. Okay? Kinuha lang natin yung maximum nun. Okay? Linagay natin sa pred.2, which is a data frame. No? From I in 1 up to 100. 105 observations yun. Okay? So, feedback naman, please, class, if you got it. And the result is, saan yung pred 2 natin? Yun. Okay. Where that observation belongs, kung group 1 siya, group 2, etc. So, i-convert natin to, class, no? Alright, take a look at your pred.2. Okay, ang lumabas dito na variable name x1l, no? So, yun ang gagamitin natin dito. Okay, so ang ginawa ko dito, class, pred.2, yung x1l, linagay ko lang na yung 1 is-substitute ko yung setosa dun sa pred.2 x1l. So ito lang, class, sinubstitute lang. So lahat ng 1 gawin kong setosa, lahat ng 2 gawin kong versicolor, lahat ng 3 gawin kong virginica dun sa pred.2. Okay? So if you run this, class, papalitan lang niya, class, papalitan lang niya si pred.2, papalitan niya ito. Okay, tingnan nyo, class. Naging ano na, no? Naging words na. Setosa, virginica. Bakit, class? Kasi gagawa lang natin, class, ng confusion matrix. Although, of course, class, you can do the same way na ginawa natin sa RF. Ito, binago ko lang ng konti. Alright? So, si pred.train, class, nalan natin, no? Structure ni pred and train. Anong klaseng ano ba to? Object to. Structure niya, okay. Wait. Hindi. Sorry na. Mali. Sorry. Hindi si pred, structure ni, ni pred 2. Sorry about that. Ano ba structure ni pred.2? Yan. So, character siya class, no? Character siya. So, hindi siya factor. So, what I did here, so, nag-create ako ng isang object, pred untrain. So, as that factor ng pred.2 x1l. Alright? So, pinalitan ko tong pred untrain na to ng factor coming from this one. Alright? So, i-run ko lang to. Tapos si pred untrain ngayon, ito na siya class, no? A factor with 3 levels na. And lastly, class, ito na yung huli, no? Gagamitin natin yung confusion matrix class, pred untrain, at saka yung train data. Co-compare natin si pred untrain at saka yung train data na species. And tingnan yung class yung result. No? So this is one good thing about using the confusion matrix of caret. Kanina ginamit lang natin ano lang di ba? Table lang. Pero tingnan niyo class, no? Ang daming information. Sensitivity, specificity, positive predicted value, negative predicted value. Siguro I'll give a short description of this, no? Ito yung sinasabi ko class, yung caret talaga napaka-powerful niya for machine learning, for using it for confusion matrix. Kasi tingnan niyo naman dito, ang daming information. So, ano nangyari sa ating class? Oh, okay. Pero training data pa lang din to class, ha? So, I leave you guys to check using the same thing, okay? I-predict nyo naman for the testing data set. And when you predict it class, makikita naman natin yung sa RF, random forest, 98%. So ano kaya sa ANN? Ilang percent kaya yung magiging accuracy niya? So that's an exercise for you to do. No? Kasi train lang yung ginawa natin. So i-replicate nyo lang yung ginawa natin for train dun sa testing data set. Alright? Okay, so let me stop recording first.